Hello everyone, I'm Rahul Dandamudi. I work as a software engineer at Instagram on the developer velocity team. Today I'm here to talk to you guys about how we revamped our launcher activity to enable our engineers to use some of the powerful abstractions which Android provides. But first, I would like to take a few seconds to talk about our team. Our team is based out of New York, and we work on improving the engineering efficiency by building mobile frameworks and tools which are needed for our engineers to execute things faster. We, along with the performance and stability team, are part of the bigger core client infrastructure, which is powering all the infrastructure which is needed for our Instagram app. Any of you are interested to know more about our teams, feel free to reach out to me at the booth or any of other Instagram engineers in the audience today. We'll be more than happy to share more context on those things. So today's talk is going to focus primarily on three things. One, we are going to talk a bit about our legacy infrastructure, on which the first Instagram app was built, and how it ended not being a scalable solution. And how we approached solving the problem is the other part which we will be discussing. And the third is how we rolled out this level of higher complex infra changes to our users without affecting the end user experience, and also at the same time not affecting the efficiency of our engineers. Cool. How many of you here have heard about Activity Group? Yeah. I myself, before I joined Instagram, I never heard about this. Before joining Instagram, I did work on Android for quite a while, so still I didn't hear about this. So when I joined Instagram, I was looking through our code and came to know about that our launcher activity was extending the Activity Group. So that made me curious, and I started digging through what's an activity group, and this is the definition which I found. Activity group is a screen that contains and runs multiple embedded activities. So in the generation before fragments, we had this concept of where we are using multiple activities on the screen, which was not something which I was familiar with. So Instagram's first app was built on top of this, using this. But when I was reading this, I also found out that this got deprecated in API 13. So, I mean, we all know why fragments came into existence, right? Because with fragments, you can have these multiple fragments in a single activity, which can help you build this multi-pane UI, and you can reuse these fragments. Whereas with activities, that wasn't happening. So Android started moving towards fragments. But in our case, the cost which incurred to move to fragments was very high at that point, and we didn't see really a lot of benefit from moving to fragments. So we had prioritized our other infrastructure and product changes over these, and that we'll see in the end how that ended up. So just I want to go more deep into how our legacy infrastructure used to work. So here, I mean, like from the diagram, you can see that every tab in an Instagram in our old infrastructure was an activity. So it's not just a plain activity, it's a fragment activity. So those activities themselves can do fragment transactions. So all these activities were managed by activity group. The activity group was responsible for managing these fragments, like the lifecycle state of the fragment, the activity stack of all these activities put together. And this was all managed by a local activity manager, which was responsible for managing every lifecycle of these activities. So I'll talk to an example to give more understanding of how activity group used to work. Now the example which I'm taking here is, as an user, you are on our feed, and now you want to navigate to profile. So when you're doing this, you're hitting on the profile icon. So first, when you come to the feed, what the stack does is, the activity group checks if this feed exists. If the feed doesn't exist, it adds a record into the local activity manager, which basically adds it into the stack of that manager. Then when you click on the profile icon, it checks if that particular activity exists in the stack. If it doesn't exist in the stack, it recreates a new one and adds it on the stack. And at the same time, it status the view of that particular feed activity. So in the end of the day, your stack is basically going to look this way. And let's assume that at this point, you got a phone call. And based on the activity lifecycle, the activity is going to be on stop. And it's activity group's responsibility to move both feed activity and profile activity also into that on-stop calls. So that way, it is managing everything, whatever is going on at the top level, to all its child activities, I can say. Then let's say now you hit a back button. When you hit the back button, it's just going to pop off the things from the stack and resumes whatever the activity is in the bottom. So if the feed activity exists, it just resumes it. If not, you just exit the screen. All this mechanism was done through the local activity manager, which was again responsible for maintaining the record, the state of the activity, whatever is stored in the bundle, and all these kind of things. So inside each of these activities, as I mentioned, each of these activity by itself is a fragment activity. So each of the screen is composed by fragments. Fragments are the building blocks for our application at that point. But at the same time, we had, for example, if we want to navigate between two screens, what we do is we do fragment transactions and we replace the current fragment. So our architecture always thought that we are replacing the center container, which is what you're seeing. So even if you're tapping between two tabs, you're still changing the center container. There is only one container which is being always being like replaced. And as this started scaling and working out, things started getting a bit complex because till this point, all of our content used to live in these tabs. In these individual activities, we're having these things. But then we had a requirement which meant that which required us to show content on top of the tabs. The first two requirements were the direct share sheet. So to my left is the direct share sheet, which is used by our users to share a feed unit. Whatever you see in your feed, if you want to send a message to your friend, you use that direct share sheet. And the other is the inline gallery. You use this inline gallery to mainly, let's say, you want to post something to your feed or something like that. So in these two cases, as I have mentioned earlier, activity group doesn't have the ability to have multiple activities active at a time. I mean, it still can manage, but as we all know that you can't have two active activities at a time. So that's a limitation why we couldn't add an activity on top of it. But this was pretty simple for us, right? Because we could use views and we can inflate these views whenever it's needed. So that's what we ended up doing. We simply extended our launcher activity to inflate views whenever it's needed based on the product calls and stuff. But not using fragments still put an limitation because one, we couldn't get into the lifecycle callbacks, a hook into the lifecycle callbacks. Two, we couldn't have a maintainable backstack. That was a problem for us because it started, there is so much of tech debt which we are adding on ourselves, managing these things ourselves. As our product started growing, things started becoming a bit more complex. I mean, there were new requirements and the solutions and workarounds which we are putting didn't work. I'll talk through a couple of other examples to showcase like what are those hard things which we went through. So here from this video, you can see that we wanted to enable users to use the stories camera when you swipe left and the direct when you swipe right. But this was much more complex compared to the other use case because this had a complex view hierarchy and it also needed navigating to fragments. So this was not something which was possible for our infrastructure because, as I mentioned, like our launcher activity was extending activity group, so it didn't know anything about fragments or it didn't know anything about fragment transactions and stuff. So we had to come up with some kind of a solution to make this happen. So what we did was we created a controller, which is the swiping controller, which controls between the swipes which you're doing, and then added a fragment controller into our code base. So for people who are not familiar with fragment controller is something which pipes into the activity lifecycle and it passes those calls to the fragment manager and the fragment manager passes those to the fragment. So we added a fragment controller into our API. That way what happened is based on the swiping gesture. So let's say that you swipe left, the fragment controller will decide which fragment to load, and when you swipe right, then it decides that it's stories. The downside of this is though that we have hard-coded navigations. I mean, like we are saying, okay, only on the left you can show the stories camera, only on the center you can show the feed, only on the right you can show the direct. So this was like you have hard-coded and there is no way of like, if you want to say, do some A/B testing to dynamically change and see how the users are reacting for that. I mean, we didn't have that ability. So ultimately, we were able to get this working, but then we had another fun experience with the stories viewer. So you'll see here in the animation. So what happens is, I should have slowed it down, but what happens here is when you click on the stories camera, the story, there is an animation which is happening. When this animation is happening, it's more like a translation which is happening, and we want to be able to update the fragment beneath it. But as I said earlier, our infrastructure was always expecting that you are replacing the center container. So that means there is only one fragment that is alive. We can't have more than one fragment alive at a time. So that means that you can't really perform this because you can't do any animations or updating the UI for the fragments beneath it. So what we have come up with a transparent activity. So for context, transparent activity is nothing but you're setting the style of that activity to be transparent with the window background being transparent. So we have done that. That way what we have done is using the transparent activity, we started performing these animations. And that helped us to update the UI which is beneath it. But as we started scaling, as a teams, we started growing. There were more products which are being added. There were new engineers who are coming in, and everyone were facing the same trouble. Like, what is activity group? I have read many posts where many engineers who have started working at Facebook, some of them have the first post which is like, what is activity group? That's what we were starting to get. So as we are scaling and there were more product and more features which are being added, things were not working for us. It was affecting the developer velocity of our engineers. It was also affecting the lot of hacky workarounds which we have to do, and maintaining and managing this API was getting a lot of harder for us. So at this point, because this was starting to be a developer velocity problem, our team took over this to revamp this infrastructure. But before we started working on this, there were certain hard set of rules which we set for ourselves. One, as I mentioned earlier, each of those tabs were activities, fragment activities. That means they have their own fragment manager and they have their own backstack. So we had to continue that requirement where we allow each of those tabs to continue having their own backstack. The second problem which we have come across is none of them were, at the lower level, we are unable to perform true fragment transactions. We had to use fragment controller, or we have to use some other hacky way arounds to get it done. The third expectation was to remove any deprecated APIs from our code base, and also encourage our engineers to do animations very quickly, and also remove the requirement of hard-coded navigations, which I have talked about in a while. So this is the new infra approach which we have came up with. We wanted to change our launcher activity to extend fragment activity. So when we extend the fragment activity, we were able to make all of these tabs, including the direct and the stories, as fragments. But this implementation still had a limitation because, as I mentioned just now, a fragment activity can only have one fragment manager. So that means it can only have one backstack. But for us, we needed to have multiple backstacks in the app. So what we have done is we have incorporated again the fragment controller. So each of these tabs have a fragment controller. The home, the feed, stories, direct, everything has its own fragment controller. So that means they have their own fragment manager, and that would lead to their own backstack. So this was good. So what we have done as an abstraction is we have added something called as host manager. So the host manager's responsibility is to manage these multiple fragment controllers. So you have these 7 fragment controllers which needs to be managed by someone. So we just created an abstraction which is the host manager. So what happens is the new fragment activity which we have created is going to start sending events, like let's say that on create, it dispatches an event to the host manager saying, hey, I'm created. On resume, it's going to do the same. On stop, on destroy. So for all the lifecycle events, it's just going to tell the host manager, hey, I'm at this state. Whatever you want to do, please do it. So then the host manager talks to something called as host. Host is nothing but a object which is basically consists of the fragment controller for each of those tabs, and also what is the tab name. So that together we created an object. So the host manager identifies the active host. So let's say now I'm on feed, the event should only be sent to feed. If I'm on profile, the events were sent only to profile. So the host manager's responsibility to keep track on which host is active and what is in the backstack. So it is also responsible for maintaining that backstack of hosts. And once the host gets this message, the host passes it to the fragment controller. And then the fragment controller passes it to the right fragment, which is active at that time. So when we see this in a theoretical level, this all seemed great. I mean, this when I came up with this solution, I felt like, okay, this is going to work. I'm not going to have any problems. But there were some really like crazy bugs which I encountered, which we'll see one of them just to give like how much hard things I had to go through. So this is a crazy bug: fragments overlapping on each other. So this bug was reported to us by one of our employees during our early dogfooding stages. And this took me a week to repro. So in order to repro this, I had to go to the developer settings, change the background processes to no background processes, and then come back, open the app from the app icon, put the app to change tabs so that I'm on feed, I go to profile or something, and then I put the phone to sleep. And I had to wake up the phone only via my fingerprint. And that was the reason why, and that was the repro steps for this bug to happen. If we go deeper and try to understand why this was happening is, as I mentioned earlier, we were trying to manage multiple fragment controllers. So each of the fragment controller doesn't know anything about the other one. So we are just saying, you do this, you do this, you do this. So what was happening is, whenever there was a low memory situation, the fragment beneath was getting destroyed. So that means the fragment controller, which was beneath, was destroying its fragments. And whenever the fragments are destroyed, the fragments move through a lifecycle event, and they move from the destroyed phase to an initializing state. So that initializing is the first state of a fragment before you draw or before the onCreate view or any other events. So it's in the initializing state. So when I was backgrounding the app or putting the phone to sleep, what I was doing was I was passing an on-stop call to all the controllers, not just the one which was active. I was passing it to everything because I wanted to see if that's going to help us with OOMs or memory management. So I was passing the on-stop call to everything, and what that was doing was it was changing the state of that fragment from initializing to onCreate view. And on create view, the layout inflation was happening, and that was leading to this problem. So in order to fix this, what I have done is, we have basically started keeping track of what host has been started and what is the state of that host internally, and thereby we are updating the host based on the current state. That way we have ensured that it's going to work in parallel for all the lifecycle states, and it's going to be there as expected. So we came up with this solution. We came up with the solution which I just talked and the new infrastructure. But testing this wasn't something which is simple, right? Because we had to figure out how we would test this. I mean, for something as complex as this, we can't just go to the manifest file, change the activity name, and be like, okay, we are done. We are going to push it to prod, because at the end of the day, you want to understand the impact of performance and stability of the app. So we had come up with two solutions. The option one was to create a shim activity. So that would be our new launcher activity. And from the shim activity, we would decide if the user is in the test group or the control group. So if the user is in the test group, we would launch the new activity which we have built. If it's in the control, we'll launch the legacy one. But the downside of this one is it's gonna impact the cold start for everyone. For all our users, we are gonna introduce a cold start regression, and that's something which our performance team wouldn't be happy with. So we had to think more, and we came up with another solution, which was to do this check inside the legacy launcher activity. So what this would do is, immediately after super.onCreate, I basically check if this particular user is in the test or control. If this user is in the test group, I finish the legacy launcher activity and start the new launcher activity. So here what happens is, there is still that cold start overhead which we have, but this is only on our test users who are in test. But at least we are not having this regression on the control user. So that way we were able to at least minimize the risk. But after we came up with this approach, we did realize that there are some risks which are associated with this, and it's also going to take us a long time to implement this whole infrastructure and his whole solution. During this time, it was very important for us to make sure that our engineers are not continuing to incorporate code into the legacy launcher, because that is something which is going to create problems for us. So in terms of risk mitigation, we have come up with a couple of strategies, and I'll share some of them. So the first strategy which we have come up with is, as I mentioned, that our legacy launcher activity code is around 1,500 to 1,800 lines of code. And it's something which is continuously updated by our engineers. Like you would see a pull request coming in daily or 2-3 pull requests. So we had to make sure that our engineers are not just adding any business logic to the old one and all, not to the new one. And also, as I said, like this has been there for a long time. So there is a lot of business logic which is in there, which we have to ensure that we weren't missing. So the first step which we have done was we moved all this code into a shared controllers. So the controllers were responsible for holding on to the business logic. So we had multiple controllers. We had something to handle deep linking. We had something to handle the navigation. We had something to handle any business logic conditions and stuff like that. So all these controllers were talking back to these launcher activities, both to the new and legacy one. So that way, the legacy and the new launcher activities just became stubs. They were nothing but stubs. They didn't have any code except the lifecycle callbacks. It had all the lifecycle callbacks like create, start, and stuff like that. And there was the other part of the code which was there in the new one was it was talking to the host manager. So that way what happened was even if an engineer comes in and he wants to add a new code, he was adding the code into the controller, and we made sure that code works between both the legacy and the new one. So that way we had trained our engineers to contribute everything into our controllers, and that way things didn't go nasty. Like when we are testing something, we found out, oh, this functionality doesn't exist because we didn't pull in that code. So we wanted to avoid that. The other thing which we have done, I guess, as engineers, which I have learned, which we should do a lot, is communication. So this is something which I have done extensively for this project. We have communicated very heavily with our product teams because we have a lot of engineers in New York and we have a lot of engineers in California. So there's a lot of discrepancies which happen if things get lost and stuff. So we communicated very heavily, like at least once in 3 to 4 weeks, saying what's the progress, how many milestones we have hit, what's going to happen and stuff. But even these two strategies weren't enough because still the things can fall between the cracks. So what we have done is we have created a custom lint rule. So, sorry. So we have, okay, I think I have the animation here. So anyway, you have seen in my lint roller, so that's good. So we have created a custom lint rule. So the custom lint rule, what it does is, if let's say that you have put out a new pull request which is affecting any of these classes, I would be subscribed on those changes. And that way, if somebody is doing a mistake, I can go and say, hey, this is not the way we should be doing. This is not the way we are expecting to go forward. These are what are happening. So that way we tried these 3 strategies and it did work out well for us. In the end, we were able to have, I think we never had any issues with somebody doing the wrong thing because we tried to close the doors as much as possible at the right time. Then once we have got these strategies, once we have got this working solution, I mean, once we are done with the development, we wanted to roll this out. Rolling this also was very complex because, as I said, like there is a lot of things at stake. I mean, one, you can push it out into production and people won't be able to open your app. That's not going to be a good sign for our end users. So what we have done is we have done a slow rollout process. So once we have done with development, we push to our QA, where the QA had done very extensive testing for about 2 to 4 weeks. And once we identified a lot of issues in QA, we were able to identify a lot of crashes, a lot of functionality bugs, and all those kind of things. And once that got into the QA, and once things started stabilizing in QA for a while, we moved it into our alpha channel. In the alpha, we still found out more crashes, more bugs. We tried to mitigate them again before we push into alpha. So we went back again to development. There are many crazy bugs like the one which I have shown you, which came across, which we never expected. And so we had to go back, spend a lot of time into the process of developing these things. And once things started stabilizing in alpha, we did push it out to beta, which still had some issues. And we tried to figure out. The one thing which I learned is it had to do with the scale, because in QA, when they're doing the testing, there were around like 10 people who were trying to test. In alpha, I think we have around like 500,000 or maybe less than that users. But when we are going to beta, there is more people and more subset of devices, more countries who are participating, more users from different network conditions, the device states. So this was helping us a lot as we're rolling out, and it helped us to clean off a lot of bugs before we pushed into prod. So once we fixed everything in beta, I felt happy and I told my manager like, hey, we are going to push into prod and the 1 week we are going to be done. So, but to my surprise, that didn't happen. So when we pushed into prod, we saw there is a big nasty bug with our logging. So our logging framework wasn't working as expected. So all our metrics were like down. I mean, like they were like minus 20, minus 30% down. So we had to go back, start investigating, and try to do this around. After doing a lot of work, we were able to push this out. This change took us around 9 months to push this out, and we released it to prod back in May to all our users. Some of the takeaways which I had from this project was first the developer velocity win. So for us, we enabled our engineers to start using fragment transactions, which is something which everyone in the industry are familiar with. Before, we weren't able to do those things at the true level. And also one other thing I forgot, I'll just add up, is we were unable to call get activity. So you can't call get activity on the top, on the lower level, because what happens is get activity returns, expects a fragment activity to be written. But our framework wasn't a fragment activity, it was an activity group. So if somebody by mistake comes in and adds a get activity, it just crashes. And there has been a post by multiple engineers who made a post and be like, why is this crashing? Because I was just doing get activity on after on resume, but it was still crashing. So those kind of bugs were really slowing down our engineers. So this is a big win for us in terms of a developer velocity. At the end of the day, it wasn't just a developer velocity problem. We were able to affect very key metrics in terms of performance and stability. We were able to reduce our cold start time by 2.5%. We were able to reduce our crashes by 11%. So these, at the end of the day, helped us to fix a lot of these things and help a lot of performance and stability of our app. The third takeaway for me was the rollout. I think testing such a big change, especially A/B testing something as big change as an infra change like this, is very difficult. But at the end of the day, I think a lot of beta and testing and beta signals helped us to uncover some of the subtle bugs, which seem to be a perfect solution. So yeah, that's all I have.